All right. Hello and welcome everyone. My name is Peter Lenz. I am the Pulmonary and Critical Care Fellowship Program Director here at the University of Cincinnati. I'm going to be talking right now a little bit about basic respiratory physiology, some basic normals, basic ventilation, basic oxygenation, what we do, and compare it a little bit with some of the things that you can find on a ventilator. I'm going to start off just talking a little bit about the difference between negative pressure ventilation and positive pressure ventilation. So when we take a deep breath, our diaphragm drops, basically creates a vacuum, air is sucked into the lungs, it goes down, fills up our alveolar air sacs, and we can oxygenate, and we can get that oxygen to go into our capillary membrane at the interface of the alveolar air sac and the capillaries. And then that can get into our bloodstream, go to our heart, and deliver to the rest of our body. When it comes to positive pressure ventilation, we are pushing air in. We're no longer requiring necessarily the diaphragm to drop to create that vacuum. We are taking a ventilator and positively pushing the pressure in. So that's the difference when it comes to negative pressure and positive pressure ventilation. With that being said, there's a couple of physiologic effects that we should be aware about, particularly if a patient is really dry or quite hypovolemic. Sometimes we can actually take positive pressure ventilation if we overdo it and end up squashing the vena cava and some of the return and blood flow to the heart. So once again, when we talk about positive pressure ventilation, we are putting pressure in and we're putting air and driving it into the lungs. So let's talk a little bit about some respiratory normals, just some things that you and I are doing right now, breathing, right? All right, here's some terminology we're going to take a look at. Respiratory rate, we could also call that frequency. Tidal volume, how large is the breath that we take with just a normal quiet breath? And then the FiO2, what's the percentage of oxygen in the air that we're breathing right now? Real quickly, on planet Earth, this is always 21% if you're breathing ambient room air, or as a decimal, 0.21. Now when we come over here, we take a look at our respiratory rate, probably somewhere between 10, 11, 12 breaths per minute. For easy math, let's say 10 breaths per minute. And probably a tidal volume, depending on your height, because the lungs are a little bit larger for taller people. Tidal volume is probably somewhere between 400 cc's or 400 mLs and about 600 mLs from anywhere depending on height. So for easy math, we're going to say 500 milliliters or 500 cc's, and as a decimal, that's 0.5 liters. This is normal breathing, what we're doing in gas exchange. If we combine these two and take our respiratory rate times our tidal volume, we get what's called minute ventilation. So 10 breaths per minute times 0.5 liters equals 5 liters per minute of gas being exchanged through our lungs. So when we are doing normal homeostasis, and we want oxygen to be the terminal electron acceptor for aerobic respiration and aerobic metabolism to make all that ATP. Essentially, we're requiring about 5 liters per minute of gas exchange with oxygen coming in and then carbon dioxide being ventilated off. So the two major priorities for the lungs, right, is oxygenation over here, and that's dealing with getting oxygen to the tissues so that it can be the terminal electron acceptor. And over here, we got ventilation. We're getting rid of carbon dioxide. So I'll say carbon dioxide removal. So these are the two major things that our lungs are performing. And real quickly, on a ventilator, to do positive pressure ventilation, there are essentially two different things we can do for each. If we simplify down how to artificially ventilate or oxygenate somebody, there's two things for each wing here. Right? And taking a look at this, oxygenation, we can increase the FiO2 from 21% all the way up to 100%. On a ventilator. There's also different ways we can give oxygen via nasal cannula or high flow nasal cannula, or Optiflow, or masks, or Venturi masks, or non-rebreather masks, and we can go up on a ventilator up to 100%. Now later on you'll hear a little bit about what we call PEEP, or positive end expiratory pressure, and when we talk about PEEP, we're talking about distending the alveolar air sacs so we can keep them open. For lungs that are stiff or not wanting to budge very much, we can increase pressure there, even that's there at exhalation, to help this. Ventilation, there's two things. Once again, it's the minute ventilation. We can augment respiratory rate, and if we increase respiratory rate, we will blow off more carbon dioxide. And over here, we can increase the tidal volume or augment the tidal volume if we need to get rid of more CO2. So for oxygenation, you can change FiO2 and PEEP on a ventilator, and for ventilation or CO2 removal, we can change the respiratory rate or change the tidal volume.